Hi everybody, I'm going to look at a sine wave today and look at some instantaneous values and how I can go and understand how in an AC circuit how voltages are continuing to increase and decrease and what is happening at each individual point in time. So with any AC source, we know that based on that conductor inside of our source passing the lines of magnetic flux, it's going to create an AC voltage, a voltage that is continuing to increase and decrease throughout its cycle. So when we look at a waveform, we're going to have two values. For this, we can look at the value of voltage, and then this red can be the value of current. So we start off at 0, where those lines of magnetic flux aren't cutting any, the conductor is not cutting any lines of flux. When it passes perpendicular to the line of magnetic flux, that's when it will be cutting a peak voltage. So if we have a peak voltage, and I want to know what at any instantaneous point in time, I can go to any point on this sine wave and calculate what the magnitude of that voltage is. So in this waveform, if we looked at voltage and current, this would say that voltage and current are in phase. They're peaking at the same point. They're also at 0 at the same point. But more importantly, actually, is that every instant in time, when voltage is at 45 degrees, current is at 45. So it's not just at one point in time. Every single point in time through this entire waveform, voltage and current are at the same instantaneous value. Okay, not necessarily magnitude, but if it's at voltage is at 32 degrees, current will be at 32 degrees. So if I have a peak voltage of 170 volts, and I wanted to go look at what my instantaneous value is around 45 degrees. So I'm looking for what is happening at, let's say 45 degrees, let's make it easy. So at what is happening at 45 degrees. So I take my Emax, which is 170 volts, and I will multiply it by the sine of 45. And when you do this, you're going to have something, it's going to be right around 120 volts. So when we look at this, another name that's going to be for this 120 volts, also for that sine of 45, is an RMS value. So if we were to take a voltmeter and measure the voltage at a receptacle, and it said 120 volts, that would be the effective voltage, what happens at the 45. So at 45, the other name we can give to this is the effective. It is also known as an RMS, a root mean squared value. So we can take from our peak value to any instant in time with voltage or current by using this same concept. So I hope this has helped. See you in the next one.